You know, when you buy a faster car and suddenly you end up spending more time sitting at the exact same red lights.
Oh, yeah. The bottleneck doesn't actually disappear. It just, moves further down the road.
Exactly. And in the software development world today, we are dealing with this massive structural bottleneck. You could probably call it the AI paradox.
Right, because we have these incredibly powerful AI coding assistants now.
Yeah, they're generating hundreds of lines of code in seconds. I mean, developers are writing boilerplate and feature logic faster than ever before in human history.
But all that code just slams into a wall.
Right.
It creates this unprecedented backlog of uh, manual review work, security audits, and just orchestration headaches.
Which is exactly the core focus of our deep dive today. We are looking at a stack of technical sources covering the release of GitLab 19.0.
Which officially launched on May 21st, 2026, for those keeping track.
Yeah. And the mission here is to explore how this update fundamentally shifts the platform. It's moving from being just a sequential toolchain to what an article in the news stack described as a full DevSecOps orchestra.
I love that phrasing.
It's good, right? We're breaking down how GitLab 19.0 is designed to fix the infrastructure and governance around the AI rather than just giving you like another code generation autocomplete feature.
It really is a profound shift in product philosophy.
Yeah.
They're actively trying to solve that production paradox by automating the manual handoffs. The stuff that happens between the moment the code is drafted and the moment it actually ships.
Absolutely. But before we get into the mechanics of how they're actually pulling this off, I want to explicitly mention that this deep dive summary was created by ALM Toolbox.
Huge thanks to them.
Yeah, they are a premier partner of GitLab, a managed services provider, and just genuine GitLab champions. So a big thank you to them for curating all these architecture notes and articles we're unpacking for you today. So to understand the architecture of 19.0, we really have to start with the problem of developer flow. Like, how do you keep a human developer in the zone when AI is just flooding the pipeline with output?
Well, GitLab's answer is this overarching initiative called Developer Flow, which in 19.0 is finally moving out of general availability and extending across the entire merge request lifecycle.
Okay, so what does that look like in practice?
Think of it as a single persistent AI agent that just lives inside the NR. It doesn't just write code. It addresses reviewer feedback, researches unfamiliar code bases for you, and it splits oversized MRs that have gotten way too big.
Wow, okay.
It even resolves merge conflicts on long-running branches.
Okay, wait, let's unpack that last point, because letting an agent autonomously resolve merge conflicts, that sounds terrifying to me.
It does sound a bit sketchy at first.
Right, like resolving a syntactic conflict, like two people adding a variable on the same line, that's easy. But semantic conflicts where the actual underlying business logic clashes, those are incredibly nuanced.
Oh, absolutely.
So if we let an agent autonomously resolve those, what stops it from just, I don't know, force pushing over a protected branch and silently deleting custom logic just to make the build turn green?
Well, the guardrails for the agent's autonomy are actually the most critical part of the whole design.
Okay.
First, just on a purely infrastructural level, the agent strictly inherits your existing permission model. It respects branch protection rules.
Okay, so it can't go rogue.
Exactly. It cannot force push over a protected branch under any circumstance. But addressing your point about semantic logic, the system doesn't just rely on, generic LLM training data to guess the resolution.
Then how does it know what to do?
It relies on the explicit implementation of two new configuration files.
Yeah.
They are agents-s.md and agent.config.iml.
So it's essentially reading a local map of the repository before it makes a decision?
It's actually much more than a map. The agents-s.md file acts as the contextual memory for the repository. So it contains your project-specific conventions, architectural decisions, and, domain-specific quirks. So before the agent attempts a resolution, it ingests all this context. Then it uses the agent-config.iml to actually spin up an ephemeral environment.
Wait, really? It spins up its own environment?
Yes. It compiles the code and runs your test suites and pre-commit hooks before it ever commits the resolution. It isn't just predicting the next logical token, it's empirically validating that the resolution passes your specific test parameters.
That is, it's basically mimicking the workflow of a diligent junior developer.
Exactly.
It reads the team's onboarding manual, reviews the style guide, and actually runs the local test suite to see if the build goes green before asking a senior engineer for a review.
You nailed it.
Yeah.
And that changes the dynamic completely because it means two different projects in the same organization can exhibit completely different agent behaviors based on just those configuration files.
Right. It ensures the output actually matches the local environment standards.
Yeah, and when it does commit a fix, it leaves a really detailed summary comment on the MR explaining exactly what logic it chose and why. So human reviewers aren't left trying to, like, reverse engineer an AI's decision-making process.
I definitely see the value in that.
Mhm.
But I have another concern here.
Sure.
If we have AI agents autonomously moving code, spinning up ephemeral environments, running test suites in the background, that introduces a massive security surface area.
Oh, for sure.
More automated workflows mean more pipelines that need access to sensitive credentials, database passwords, API tokens. We can't just have those keys sitting around in plain text environment variables for any background bot to scrape.
No, you really can't. Credential sprawl is pretty much the silent killer of automated pipelines. And that vulnerability is exactly what GitLab 19.0 targets next with the new GitLab Secrets Manager.
Which is now in public beta for premium and ultimate tiers, right?
That's right. And historically, teams have had to wire up these really complex integrations with external tools like HashiCorp Vault or AWS Secrets Manager to handle this securely.
Yeah.
It's always a headache.
Right. So building it natively right into the platform fundamentally alters the default security posture.
Because the traditional way of doing CI/CD variables always felt way too broad. Like, you store a credential at the project level, and any job added later can potentially access it. It's like leaving a master key under the mat for an entire office building.
Exactly. Anyone who finds it gets in everywhere.
Right. But this new Secrets Manager changes the architecture to enforce least privileged access natively. It's more like a hotel keycard program to only work on your specific floor for a specific job.
That is a perfect analogy. And the source is actually, quote, Manav Khurana, GitLab's chief product and marketing officer, saying this update, quote, flips the default.
I want to look at how it mechanically achieves that. What does flipping the default actually mean here?
It means moving away from implicit trust. In the new Secrets Manager, credentials are cryptographically bound to specific pipeline execution contexts.
So you define explicit conditions, like a specific branch, a particular environment, or a designated runner. When a job requests a secret, the platform generates a short-lived ephemeral token that is only valid for the exact duration of that specific job.
And then it just vanishes.
Yep. Anything outside that highly restricted scope cannot even conceive that the secret exists at all.
The structural alignment there is just brilliant because it uses the exact same group and project hierarchy that you're already using to manage your repo access. You aren't forced to map user identities across two entirely different systems.
Which is a huge time saver.
The auditability must be incredibly precise, too.
Oh, the auditability is a straight line. If an anomaly happens, you trace it directly within the GitLab audit trail, and it's linked to the originating pipeline and that specific ephemeral token.
So no more forensic detective work.
Exactly. You don't have to cross-reference timestamps between your code repo logs and a separate third-party vault just to figure out what happened.
Speaking of timestamps and security, the sources highlight another back-end cryptographic addition in 19.0 that I find super fascinating.
Oh, the HMAC signing.
Yes, HMAC signing tokens for webhooks. So I understand the baseline threat here. Webhooks usually rely on static secrets in the header, right?
Yep.
Which makes them vulnerable to interception and replay attacks.
Right, where a bad actor captures the payload and just maliciously re-triggers a pipeline over and over.
Right. So how does 19.0 mechanically solve that replay issue?
Okay, so it implements the standard webhook specification. When GitLab fires a webhook now, it doesn't just send a static secret. It computes an HMAC SHA 256 signature that cryptographically hashes together three things: the webhook ID, the payload itself, and the exact timestamp of the transmission.
Integrating the timestamp into the hash is the really clever part.
It is, because it totally solves the temporal vulnerability. When your receiving system gets the payload, it recalculates that signature. If an interceptor altered even a single byte of the payload, the signature breaks immediately.
Right, standard hashing.
But more importantly, if someone intercepts a perfectly valid webhook and tries to replay it unaltered, say 10 minutes later, the signature might technically match the payload, but your receiving system is going to reject it.
Because the timestamp baked into that hash is stale.
Exactly. It completely neutralizes replay attacks.
It's just a really elegant cryptographic lock. But I want to shift our focus for a second to the actual physical location of these systems.
Okay, okay.
Securing agents and secrets in the cloud is one thing. But what if you operate in finance or healthcare or government?
Right, highly regulated spaces.
Yeah. For teams working in those air-gapped environments, sending proprietary code-based data out to an external cloud AI model for processing is often a total non-starter. They just can't do it.
The industry has definitely faced a severe capability gap there. Regulated teams have largely been stuck using these rudimentary, outdated local tools, while cloud-connected teams just pull way ahead.
Right.
But GitLab 19.0 is addressing this by massively expanding open-source model support for the Duo agent platform self-hosted.
And looking at the supported model list they've got, they really aren't pulling punches. They've integrated support for Mistral DevStrol 2.123b, GLM 5.1 FP8, Kimi K2.6, Minimax M2.7, and even local support for Gemini models.
Yeah, the inclusion of heavy-hitting models like that Mistral 123 billion parameter architecture is hugely significant.
That's a massive model to run locally.
It is. But it means teams running in network-restricted environments can finally execute deep, complex logic and agentic workflows entirely offline. You don't have to sacrifice the reasoning capabilities that you normally only get from massive cloud providers.
So you no longer have to choose between strict data compliance and modern development speed.
Exactly.
The documentation also highlights hybrid deployment capabilities, which seems incredibly pragmatic for enterprise environments, like mixing and matching.
Oh, hybrid deployments are a game changer. They allow organizations to route tasks based on data sensitivity and latency requirements.
How does that work in practice?
So you can configure the system so that your highly sensitive core banking logic is exclusively processed by a self-hosted open source model on your own bare metal. But then less sensitive peripheral code, maybe documentation or front-end formatting, that gets routed to a faster managed cloud model.
Oh, that's smart. So you control the specific data perimeter for every single project.
Exactly.
And this democratization of AI isn't just happening at the infrastructure level either. It's happening at the billing level too, which is huge.
Right, the new credit system.
Yeah. Because previously, if a team was utilizing the free tier for self-managed Enterprise Edition, accessing these advanced AI capabilities meant a massive, sweeping license upgrade to Premium or Ultimate for the entire organization. But in 19.0, they've introduced a direct mechanism, purchasing GitLab credits.
It basically acts as a dedicated consumption model. Organizations can define a monthly credit amount, commit to an annual term, and then just utilize a shared pool of credits across their whole instance.
So it removes the friction of a massive enterprise license overhaul. Smaller self-managed teams can just experiment with and deploy agentic AI immediately.
Yep, it really lowers the barrier to entry for intelligent orchestration. But orchestration only really matters if the underlying code is safe.
Oh, true. We've discussed securing our own proprietary code and our own pipeline agents, but modern software relies so heavily on third-party dependencies.
Way too heavily sometimes.
Seriously, you import one library, which quietly imports 3 others, which import 10 more. How does 19.0 handle the risk of importing vulnerabilities from the outside world?
Well, this brings in the general availability of SBOM-based dependency scanning.
Which stands for Software Bill of Materials, for anyone unfamiliar.
Right. And the critical mechanical upgrade in 19.0 here is that the scanner now officially catches transitive dependencies for Maven, Gradle, and Python projects using automatic graph resolution.
Okay, I really want to highlight the difference between graph resolution and manifest scanning because it's crucial. A manifest scanner just reads your lock file or dependency declaration, right? It only sees the library you explicitly asked for.
Exactly. But transitive dependencies are the libraries that your library depends on. They're sitting layers deep in the architecture.
And direct declaration scanners are totally blind to the bottom of that dependency tree.
They are. So in 19.0, if a lock file isn't present, the analyzer automatically invokes the underlying package manager to build and resolve the entire dependency graph in memory before it scans.
Wow, so it charts every single nested connection.
Every single one. And if the environment prevents graph resolution for some reason, it gracefully degrades back to manifest scanning. So you always maintain at least a baseline layer of coverage.
Finding a vulnerability buried 6 layers deep in a dependency graph is vital, obviously. But for the developer, it just creates another chore. You know, manually updating nested version numbers, praying it doesn't break a downstream API, fixing the conflicts. It's incredibly tedious work.
It is the worst. which is why the most compelling experimental feature in this release is auto-remediation, which is currently focused on Ruby projects.
Oh, tell me about this.
Following a pipeline run, the system will automatically parse the vulnerabilities, isolate the highest severity issue that has a known stable patch, generate the necessary manifest file changes, and then use a dedicated service account to open a merge request with the fix.
Wait, my immediate concern there is alert fatigue. If an automated bot is just constantly firing off merge requests for every minor library update, the repo is going to become completely unmanageable. The noise-to-signal ratio would be terrible.
They've actually anticipated that exact friction. The system is hard-capped at a maximum of 3 open automated MEMRs at any given time per project.
Oh, okay. That makes sense.
Yeah, it acts as a throttle. It ensures the security updates are continuous, but they don't just overwhelm the review capacity of the human engineering team. The AI drafts the solution, but a human still owns the merge button.
That is perfectly framed. And it reminds me of a brilliant observation from David Gervin, an AI security researcher at Sumo Logic, who was quoted in the Newstack article.
Oh, I know the quote you're talking about.
Yeah, he pointed out that most AI coding tools are hyper-focused on solving problems that consume about 52 minutes of a developer's day, the actual typing of syntax. GitLab 19.0 is asking what happens during the other 7 hours.
Yes, the orchestration, the dependency patching, the security governance, the secret management, that is where the actual time is lost in modern development.
Exactly. Gervin emphasizes that engineering organizations have to wire up execution governance and observability mechanisms before they unleash autonomous AI agents into their code base.
And the article uses that fantastic, simple analogy. First pants, then shoes.
First pants, then shoes. You have to build the secure infrastructure, the DevSecOps orchestra, before you hand the AI the instruments. If you just unleash autonomous coding bots without secrets management and dependency safeguards, you are going to find out the hard way what an unsupervised script decided to modify on a Tuesday afternoon.
Yeah, the governance absolutely must precede the automation.
All right, let's bring all this architecture back down to the day-to-day reality for you, the listener. Beyond the overarching AI agents and security overhauls, there are quite a few workflow and quality of life improvements in 19.0 designed to reduce cognitive load.
Oh, definitely.
Let's look at how these address the actual friction points developers experience right in the UI.
Well, the most immediate upgrade is the introduction of rapid diffs, which is currently in beta.
Oh, this one is a lifesaver.
Truly, anyone reviewing a massive architectural change knows that browser crashing pain of waiting for a merge request with hundreds of changed files to render the document object model.
It just completely locks up the tab.
Exactly. Rapid diffs overhauled the front-end rendering to deliver faster initial loading, prevent memory bloat, and actually allow for smooth scrolling through those massive change sets.
We're also seeing a fix for a long-standing mismatch between agile planning and repository tracking. Configurable work item types. Yeah, historically, teams have had to shoehorn their diverse planning structures into rigid issue or task buckets. Now, you can define custom schema types, like you can have a user story, a bug, or a database migration, complete with dedicated custom fields and distinct icons. It finally aligns the tool with how product teams actually conceptualize their work.
And along those same lines, we're seeing the introduction of customizable default MR titles using templates.
Oh, nice.
Yeah, rather than allowing an MR title to default to an unreadable string of branch names and hyphens, administrators can enforce a template. So, for example, formatting the title to always include the issue ID and a standardized prefix. It enforces naming conventions systematically rather than relying on human memory.
And for platform engineers, the detailed CI/CD catalog analytics will be a massive visibility upgrade.
Oh, huge.
You can now pull up a dashboard to see exactly which projects across your entire organization are consuming your CI/CD components, and more importantly, exactly which version they are pinned to. You don't have to guess who is running a deprecated, vulnerable pipeline component anymore. The data surfaces the exact targets for an upgrade campaign.
However, with all these advanced orchestration features, we do have to mention that GitLab is enforcing stricter back-end architectural requirements. Listeners managing self-hosted infrastructure really need to prepare for some hard deprecations.
Give us the bad news.
PostgreSQL 17 is now the absolute minimum database requirement to support these advanced queries. If your instance is on version 16, the upgrade will just straight up block.
Oof. Database upgrades are the vegetables of system administration?
Yeah.
What else is being deprecated?
Redis 6 support has been entirely removed from the caching layer. Your infrastructure needs to be running Redis 7.2 or Valkey 7.2. Additionally, Native Linux packages for Ubuntu 20.04 and SUA's distributions have been formally discontinued. The underlying operating systems and databases just must be modernized to support the load of these new agentic features.
Honestly, it's a necessary foundation. Looking at the full scope of the 19.0 release, the overarching narrative is incredibly clear here. This isn't just the integration of a chatbot into a code editor.
Not at all.
It is the construction of a secure, automated, and tightly governed ecosystem where AI can be fundamentally trusted to operate on production systems. It really delivers on the promise of a full DevSecOps orchestra, putting the security mechanisms and the automation on the exact same platform as the source code.
It creates a cohesive environment that actually allows teams to process the sheer volume of code that modern AI tools are generating, turning that raw speed into tangible, secure deployments.
Before we wrap up today, I want to reiterate our thanks to ALM Toolbox. This deep dive summary was brought to you by them, a premier partner of GitLab, a dedicated managed services provider, and your go-to GitLab champions. Their curation really makes this level of analysis possible.
It absolutely does. And, it is a landmark release for the platform, but analyzing these capabilities leaves a really lingering philosophical question about the future of our industry.
Oh,
Yeah. If platforms like GitLab increasingly automate the resolution of complex semantic merge conflicts, seamlessly handle transitive dependency patching, and autonomously map out secret management, what happens to the underlying muscle memory of human developers?
I see what you mean. If the machine is always handling the friction, we stop practicing how to solve it.
Exactly. If a junior developer never has to manually untangle a devastating Git conflict or trace a vulnerability through a dense graph of transitive libraries, do they ever develop that deep, intuitive understanding of how enterprise architectures actually hold together?
That is a fascinating point.
Right. In a world of perfectly orchestrated agentic CI/CD, does the human engineer remain the composer directing the symphony, or do they slowly become just an audience member?
Or rewriting the music, or just buying a ticket to watch the machine perform, that is definitely something for you to mull over on your commute. Thank you for joining us for this deep dive into GitLab 19.0. Log into your instances, audit your infrastructure, check out those new agents.md configurations, and we will see you on the next one.